different researchers doing some things on the data set using some data science. And that thing, after there, we can reveal that, okay, this is the process that this researcher do this thing, and now the result is this. Okay. For the another researcher, is another kind of black box. They have to find out, they have to do something after getting some experience on data science. If they have a good skill, then they find out something from that black box and they can produce a very good result. And that's why we can see that though a data set is available online, anyone can access it. But using that data set, lots of research are going on, and the results are coming different due to this black box things. And okay, my sister. Okay. Now this black box, it means the data science. Data science is a combination of three major things. First, it's a domain knowledge. You must have domain knowledge on the data set. Then after you can perform data science. Otherwise, if you are not able to understand data set, you cannot do anything. Okay. Like medical data, I may be expert in data science, but I cannot handle medical data set until I have not contact with the expertise from that domain. From some doctors, we have to contact. And then after computing, in computing, you can find machine learning concepts, big data, database, these concepts are there, programming concepts are there. And the third part, sorry, is mathematics. There are lots of mathematics are there. Okay, like modeling and simulation, some statistics are there. Mixing of these things, you can do something so that you can perform some operation on data set and find different results. This is the main roadmap of this session, this lecture. And the session starts how we can evaluate a data set efficiency. The data set is efficient or not. How we can know. Second, sorry, I have covered. How we can evaluate a predictor performance. Suppose we have some kind of machine learning algorithm, and how we can evaluate it. And the third question we are covering in this, we will cover in this session is how we can perform data transformation. It means you can see here the series that if you have a data set, it belongs to any stream. I said earlier that it's not depend on any kind of stream. You can have any kind of data set. It's up to you. It may be agriculture, it may be geographical, any kind of, okay. And then you have to find out some efficiency, that data set is efficient or not. If it's publicly available, then you download and do something so that you can say that, okay, my data set is efficient. Then you have to perform some data transformation and reveal the black box. And after that, you get some quality of data set to feed into a machine learning or AI models. Because you know, if you want to predict anything, then you have a data set. You must have a data set. Otherwise, they cannot predict the thing. But at the end, you have to say that, okay, if I feed this data set, then what is the performance of that classifier, that algorithm? You have to see. It means this is the, if you want to do any work in data science, then you have to go from level 1 to last, the result level. Otherwise, you cannot do any end-to-end work. And this session, I try to make it end-to-end work so that the participant may get a sense of that how we can explore data set and find out some useful results so that we can do some academic project or some research oriented papers or project. These things I shall try to cover. If you have any question in between, you can ask. And here I say about dataset. Dataset you can download from anywhere. And lots of public sites are available. If you have private data, it's okay, fine. But if you don't have, then you can find any kind of dataset from a lots of sites. Like first you can see UCI. It's free of cost. You can simply log in and find out different data set. Here you can see her disease, iris, this data set. Lots of data sets are there. Similar, you can find Kaggle. Kaggle is a very good platform. You can find lots of data sets. Simply go, log in Kaggle, search your required data set, and you can find the data set. And using this link, you can download the data. Physionet, it's also a good platform. And here, paper with code. If you want to do anything in data science or machine learning, then you can find some useful implementation, some useful paper, some useful code, some data set from this site. Try these platforms. It's very good to initiate research or some project in data science or machine learning field. And then after, to finalize the works, you have to first understand, after downloading your data set, you have to analyze that what kind of data analytics, data science has been performed on the particular data. For that, you have to go on Google Scholar or another site where you can find some research. Then you type your required interest or required need. Suppose data-driven e-commerce, customer behavior. If I type, then lots of paper will come. And then find out some papers, and we have to mark at a reference, suppose 1, 2, 3, 4, from where you have downloaded the paper, so that anyone can realize that what you want to do. And then certain questions you have to answer. This is a very simple step, very first step to perform anything on data science. Paper reference, you put, then purpose of the paper. If you use some methodology, a traditional kind of methodology, like in medical science, if you download a ICU dataset, then you can find QSOFA, Apache 2, 3, like these kind of conventional methods are using. But are they used? Some machine learning, you have to write down after analyzing the paper. And then after, these things are important because we are doing some data analytics, data science. You have to mention that what kind of data they have used. It may be your data that you have downloaded, or it may be private data. If private, then it's okay. Don't worry about that. You only mention that this is the private data set they collected from the hospital or some organization. But you have to perform their used algorithm. Suppose they use random forest, for example. Then you perform the random forest on your data set and find out the accuracy of this. In this way, you can visualize the current work which is going on throughout the world. And this is your research outcome. Research outcome is the combination of three. First, data set efficiency you have to say in your research, in your project, then data transformation, and then the predictor of the performance. Now we are going to look one by one so that we can clear the concept. First, data set insight. Okay, if you have any data set, then suppose this is a data set, I can show here 1, 2, 3, 4, 5 columns and 3 records. But in actual, you can find more than 100, 200 columns, more than millions of rows may be there. Okay, you cannot see by your eyes. Okay, but for understanding, we took this sample of data so that we can visualize something. Here, if you download the data set, or you have data set, then you have some purpose. Without purpose, you don't want to do anything. Okay, suppose our purpose is to find out house type, whether this is allied type or non-allied type, on the basis of some information. Informations are house age, house facing direction, distance from a station, rent. These are the things. And these things we call that independent variables or predicator or cause. Why? Because these things say our final type, that this house is allied type, non-allied type, or this is the way we can classify it. And the last column, that's type, we call this dependent variables or outcomes or effect, because this is the effect of these columns. And your downloaded data set, this is an example. Okay, example, it means if you download a data set in any field and you find that your outcome is not there, suppose your outcome is not there, you have only the independent variables or predicators or cause, then this data set, you call them no outcome. They have no conclusion on the records. Okay. And if you have these outcome like allied, non-allied, then you say that this is supervised data set. This is a major difference between if you download any data set, you can visualize that whether your data set is supervised or unsupervised, because on the basis of that you have to perform operations. What kind of operations? We are going from last step to initial step. Last step means we have to first evaluate the performance of our algorithm. How to perform? This is out of a scope topic, but I give a overview of this, because inside, if you want to learn more, then you can go for logistic regression, MAE, what is this? Lots of mathematics are there. This is another kind of talk. Okay, we may take in future if I get some opportunity. But here, as I told you, supervised data set, unsupervised. If you have supervised, then you can divide into two types: regression or classification. Like this is supervised. This data set is supervised. Suppose because we have this type also. Now you can say that this is classification. Why? Because we have some categorical data here, allied or non-allied. It's a category. That's why we say that this is a class. We can use classification model. But suppose we have a data set up to rent, and now our target is to find out this rent. Suppose this column is not there, and our target that I want to know what is the rent on the basis of these independent variables. In this case, it becomes supervised data set. Understand my point? According to your need, according to your interest, you can change it. Okay, you can change your data set and you perform different evaluation techniques on the basis of your requirement. Suppose my requirement is changed. Now I want this rent as an output. Now this becomes supervised data set, because I know I have an outcome column in my data set that is called rent. And now here you can find that the rent is not categorical. It has some numerical value, contiguous value. On the basis of these, these inputs, it will give some kind of numerical value. In this case, we can use regression. In this supervised kind of data set, we can use supervised kind of algorithm. And if you have this categorical type, then you use classification. And suppose you have no outcome. Okay, you define that our outcome is type, elite or non-elite, and you say that this is the data set, and I assume that this is a unsupervised. Then you can use clustering mechanism, and association is there. But the question is here, because I am talking about the output, I am talking about the result. Okay, these are in machine learning AI. You can see. Okay, this is a part of machine learning topic. But here, our interest to find out performance and how you can find the performance. Suppose you are using this algorithm, this kind of model, regression model. Suppose linear regression, multiple linear regression. Then for finding the performance of these models, you have these kind of matrices like mean absolute error, mean square error. Why? Because it gives you a regression line. And on that line, it finds the error, because this is a numerical value. This finds the error. If its error is minimum, then you say that your model is good. Similarly, classification, if you use classification model like KNN, SVN, then if you want to find performance of these models, then you can use confusion matrix or AUROC curve, area under the receiver operating characteristics. These matrices are there to find out the performance of these algorithms. Similarly, if you want to use clustering, then these things are there, association, these things are there. And at the end, if this is effectiveness, then the performance is better. If it's better, then its performance is better. At the end, we can say. Suppose I want to take one example of confusion matrix, because this is very popular and very useful. If you want to do some kind of project or research, then these things you have to face. Okay, and this is a very confusing things, though we know the concepts, but especially students are facing trouble that how we can evaluate our classification model. Here we can say that we have our actual data. Actual data means what? Actual data means this data is actual, that you have downloaded, and it's inside your system, and you cannot you can do some operation on it, but the raw data set is you cannot change the raw data. It means if you download a data set from internet, then anyone can download that data set. Data set is same. Okay, this is actual. It means these types, a light type is given for these records, a light type is there. For these record, non-alike type is there. These are the fixed. These are the actual. And predicted means after using these mechanisms, they will predict something. Predict that after giving these information, 10 years east, 1 kilometer, 25,000, then your machine learning will predict. This is called predicted data. Okay, actual data is actual data set exists. Predicted, it means you have to, if you use any kind of machine learning model, then it can predict. Now you can make two-class classification, though multi-class classification is there, but for simplicity to understand, I took two-class classification model, and we divide into 4 parts. Suppose positive is 1, like here, elite, non-elite. You may consider non-elite is negative, elite is positive. Then positive, negative, positive, negative. It means in actual you have positive, and negative. In predicted, you have positive and negative. If your actual, okay, actual is there. Now, if you want to, if you want to find out, then what kind of information is there in between, then you go for predicted side, because actual is actual, you cannot change it. Predicted is changing according to your model. Okay, that's why you go from predicted side and say that your machine learning is predicted positive and your actual is positive. It means this block refer to true positive. And here you see that your prediction is positive, but actual is negative. That's why your prediction is wrong. And that's why we call this is false positive. Similarly, if predicted is negative and your actual is positive, in your data set you see that this is positive, but your prediction model saying that no, this is negative, then it's a false negative. Negative is incorrect. And if it's predicted is negative and actually is also negative, then you say that, okay, it's a true negative. And of course, if you want to find accuracy, accuracy means your machine learning is saying correct thing. Correct thing means if it's a true, then machine learning say that, okay, it's true. If it's a false, it's a negative, then machine learning also say that it's a negative. Okay, this is also a good result because machine learning is identifying the thing that this is negative. Okay, that's why the accuracy is this red color addition, true positive plus true negative. And if you divide, then you can find the accuracy. Similarly, a lots of terms are there like precision. Precision you can correlate with prediction. It means your machine learning is predicted some positive thing. Okay. Among that predicted positive, how many are actually positive? This is the precision. That's why you can find the green line. This is the positive, the predicted positive. Among these, TP plus FP, how many are actually positive? This is called precision. And if you say about recall, recall means if you have actual positive in your data set, then how many are actually predicted by your machine learning that this is positive? It means this first column refer to positive for your actual data set. It means TP plus FN. You can find here TP plus FN. And how many are actually positive? It means TP by TP plus FN. And this recall is also called sensitivity. Specificity, it's refer that you have to specify that your correct negative is negative. It's correct negative in your data set, and your machine learning specify that yes, it's a negative. Exclude it. Then you say that this is a specificity, specify. For that, correct negatives are, it means actual negatives are this one, FP plus TN. You can find here FP plus TN, and actual negative is TN. That's why TN divided by TN plus FP. This is very easy concept. If you grab this sense, then you can find out very easily. You can evaluate your machine learning very easily. Let's take an example. Suppose this is another medical correlated data set. I downloaded from Kaggle. You can also download it. Though lots of columns are there, I reduce it. Okay. Now here, if you want to find out something from this data set, then first you have to convert the data set into a way so that your machine learning can identify it. For non-computer background students or others who has little bit knowledge, then they can realize that your machine learning cannot read this, survive. They cannot know the strings. Okay, for that you have to convert these things into numeric value so that your machine learning can understand. And that's why we have level encoding. You have to first do level encoding. Okay, we are not changing anything in data set. Only simply we converting the categorized value into numerical things. 1010, if you label it, then suppose 1 for survived and 0 for non-survived, then according to that, your label encoder will provide some numerical value. And then after, you have to find out, because after that you have to apply some machine learning model. Then suppose your prediction, your machine learning, this is actual data. Remember, this data is actually available in your computer. You cannot change it. But here, this data will come according to your machine learning model. Okay, suppose it predict this level is 1, survive, it predict with the use of these inputs. They say that, okay, this is also 1, survive. And for this, it predict 0. For this, it predict, for this 1, your machine learning has predicted 0. And for 1, this is 1. For 0, it predicted 1. Now you have to find out the accuracy of this so that you can evaluate your model. How? We just learned. For simplicity, you may write first here. Suppose I have to remove this. Okay. For simplicity, you can see here, I have put 1 for positive. We assume that 1 for positive means survive. Okay. And 0 for negative, not survive. Then you put this 1, since it's 1 positive, 0 negative, 0 negative, 1 positive, like this, 0 negative, 1 positive. This is your prediction. Now you have to find out whether this prediction is true or false. Okay. You can find that your prediction is 1 and actual is 1. It means this is true. Then you write T here, true positive. And you can find here your prediction is 0 and actual is 0. That's why it's a true negative. Here you can find your prediction is 0, but the actual is 1. It means your prediction is not correct. Since you have written N, you have to choose only true and false. Since it's false, that's why you can say that this is false negative. Like that, you can find it that which one is true positive, true false. According to that, you have to sum all true positive, true negative, and you know how to compute accuracy. Accuracy is true positive plus true negative divided by total. And this is the accuracy, 50% accuracy. This accuracy is actually that you have downloaded the data set. This is actual accuracy. You did not do anything. Okay, I'm only giving a sense that how we can evaluate the things. And here, since we have lots of features or independent variables, in this you can find some, but in reality, you have more than 100, 200 columns. You have to find out which one is appropriate. Then you have some techniques. It will give you. PCA is a very good technique. It's for unsupervised learning. Now you can realize that if you have unsupervised data, then you use this. And if you have supervised kind of thing, then you can use linear discriminant analysis, LDA. These are very popular techniques to extract features, because you have lots of features, suppose 500 features. But among them, according to your interest, which feature is important, these techniques will give you. And then you have, I'm telling these things from last to beginning. From last, I told you how to evaluate your model here, and now I'm coming in middle, and how we can do something on your data set using data science. Only filling of this. Data transformation, it's a big topic in data science. We have very less time. And in this, we have normalization. It's also a very big topic. Okay. In normalization, we have a lots of mechanisms. Some of them are like mean max normalization, Z-score, or zero mean normalization. Okay, mean max, it simply translates the initial data in linearly. And Z-score, it uniform the data according to mean. Okay. Why I'm telling about data transformation? Because this is your data science. This is your black box. Okay, you have to do something here to find out, to make your data efficient so that it can predict better. Suppose the prediction is 50, at this point of time it's 50. If you perform some data transformation, suppose you mention mean max normalization, you apply you apply mean max normalization on this data set and find out the accuracy, similar things, find out the confusion matrix and find the accuracy. Suppose the accuracy is 60%. Now it's done. Now it's research, your research or project has been done because you improve something. And these things I call black box because mechanisms are there, methods are there. But what kind of method you have to use? You may modify the thing. Suppose mean max normalize. It has very simple formula. Someone developed it, very simple formula. It's converted into in linear. It means you have some value. Suppose your data point. Suppose we take this column repository rate. We want to convert it. We want to normalize it using mean max normalization. And then we want to find that what is the accuracy. How we can convert? First let me explain mean max. Here the formula is very simple. You have your old data minus mean max. It means the mean of this data, entire column data, and your new range. Suppose your range is you want to make this normalization into 0 to 1. Okay, your mean and max is fixed. You want to analyze you want to visualize this entire data between 0 to 1. It may be another range. Suppose you want to visualize this data between 10 to 20. It may happen. Okay, it's up to you. Suppose we want to visualize it from 1 to 0. In this case, suppose 31. How it's convert 31 into new value? 31, the old value minus mean of this feature. Mean of this feature is 29. And divide by max minus mean of this 36, because 36 is the maximum in this value, and 29. And then after our new range is 1 new max minus new mean, 1 minus 0 plus new mean, and the value is this. See, this is simple calculation, but this is not fixed. Okay, if you want to transform your data into different angle, you can do anything, but the result must be enhanced. This is the purpose. And these things you have to explain. You may say that I have used modified mean max normalize, and you modify something, you add something, and say that this is your concept, this is your new things, and now it's a kind of project. And since you know in mean max, you know what is the mean, what is the max. But in some scenario, if you don't know that what is the mean, what is the max, then you can go for Z score or zero mean normalization. It means you cannot use anything randomly. If you want to use anything, first go and study the basic things of that, and then after apply. Okay, if you don't, in this case, if you don't know mean and max, then you go for zero mean. No need to know mean and max. It will transform your entire data set near about your mean. Okay, this is the purpose, and this is a transform. This is a very big topic. Okay, you have I only give you sense how you can modify your data set on the basis of these techniques. And then the first one. Now I covered the last one, how we evaluate the machine learning, our classifier thing, and then how we can do something on our data set like data transformation. Now the first thing, and how we can find the data set, whether it's efficient or not. And we have a technique, a statistical test. Okay, if you perform a statistical test, then you can visualize that whether your data set is good or not. Good or not means what you want to outcome, as an outcome, whether your information is going to help your machine learning to produce a good output or not. For that, we have a statistical test. Statistical test में it's a hypothesis testing which can be used to determine whether the predicate outcome has a statistically significant relationship between outcome variables or not. What you want to know, what is your desired outcome? Is this significantly has relationship between your independent variables or not? After doing this test, you can do. But again, we have a lots of statistical tests. How we can find? We are going to see here in this session. But first of all, get the little bit knowledge. In a statistical test, we assume a null hypothesis of no relationship or no difference between groups. Then they determine whether the observed data fall outside of the range of the value predicted by the null hypothesis. They are not. And then after, if you know about data types, I saw in your data set, you have categorical data, you have numerical data. If you find out these things, then you can apply a right statistical test. And it is very important because you cannot choose any statistical test for any data set. Data set may be different kind according to your need. Okay. But before choosing a statistical test, you have to do some pre-processing things on your data set and find out that whether the data set is actually correct or not. Okay. And for that, we have some assumptions like independence of observations. Okay. It's also known as no auto-correlation. The observation variable are included in our data set are not related. If it's related, then your machine learning will not perform well. Okay, because if suppose you have similar kind of information, suppose rent, if you have rent 50 columns of rent, then what is the need of this? It should be independent of observation. Okay, homogeneity of variance, the variance within each group being compared is similar among all groups. If one group has much more variation than other, it will limit the test effectiveness. Okay, these are the assumptions. And the very important, normality of data. Your data must be like bell curve, normal distribution. If it is skewed, then you have to perform some data transformation to reduce it and then perform your machine learning. And these things are good. If you find something wrong in the downloaded data set, then it's good for you because you have to transform it and then apply your machine learning and say that I have did this transformation, therefore the accuracy is this. Suppose this is skewed, then you have a lots of mechanism to how to reduce it and take the accuracy. It means first you the third assumption is normality of data must be there. Okay. Now, if our data do not meet the assumptions of independence of observation, suppose these assumptions is not there, then what is the solution? Solution is do the experiment with different values, different structure, so that you can observe different value. But this is for all streams, as I told you. If you have mechanical or any kind of stream, you have some kind of observation. After observation, you have some kind of outcomes, and this is your data set. Okay, now the data set is there. Do these operations and perform some machine learning. It will give you some accuracy that we are discussing. And suppose our data set do not meet the assumptions of normality or homogeneity, then we have to perform non-parametric statistical test. Okay, this test has not much considerations. If you don't know much about your data set, go for non-parametric statistical test. But if you know something about your data set, you have some command, you know that okay, these are the your data set is normally distributed, homogeneity of variance, independence of observation, then you go for parametric test. It will give you very good result. And how we can choose? Since in our data set, I told you, first we have independent variables, then we have dependent, it means outcome variables. First, you have to check the independent variables, whether this is categorical or quantitative. According to that, you have to go. Suppose this is quantitative, then again you have to check the outcome variables. Outcome variables, whether it's a categorical or quant. It means in both directions, you can see that first we have to check whether our independent variables, predictors has categorical or quantitative variables. According to that, we will check our outcomes, whether outcomes in your data set, whether outcomes is categorical or quantitative. On the basis of this, suppose this is your predictor has quantitative and your outcome is categorical, then you have to choose this logistic regression and statistical test. And if suppose your outcomes is quantitative, then you find out how many predicators variables are there. Suppose here, if you want to find out, if you want to apply some statistical test on entire data set, then you can find that this is your categorical, of course, and these independent variables predicators are, these are numerical value, quantitative, and it means for this data set, you will select this logistic regression. Suppose we reduce this data up to this, only this. Then in this data set, you can find that your, and you want to predict this rent, okay? Now you find that the independent variables are house age and distance, and both are quantitative. It means we will go in this direction, and then we find the outcome variables is rent. Rent is quantitative, okay? Then after we find out how many predictors, how many independent variables are there. Here we have two house age and distance. That's why we select which one? More than two. That's why we select multiple regression. Suppose we want to do the operation on only these two fields, one independent and one dependent, then we can select simple regression. In this way, we can select. And on the other side, if your predictor independent variable is categorical and outcome is quantitative or categorical, suppose categorical, then you have to choose non-parametrical test. And quantitative, then we have to compare with mean test. And in mean test, we have to compare how many groups are compared. If it's two, then t-test. If more than two, then we have to find out how many outcome variables are there. If it's one, then ANOVA. It's more than one, then MANOVA. In this way, we have to find out the right statistical test for your data set. Okay, this is the first operation, first step. We have learned the last two steps, step 2 and step 3. This is the first one. And since we are comparing it, that's why we say that this is a compare test. Compare test means we have, suppose we compare more than two groups in MANOVA. Suppose average height of children, teenagers, and adults, then you can use MANOVA, a statistical test. And here, in regression test, these are the regression tests. They can be used to estimate the effect of one or more contiguous variables on another variables. What is the effect of rent and data set in house and type? If you rent and distance on type. Okay. These ways, and the third one is correlation test. Suppose you have more than one features, then you can do correlation test. Okay. And this is the point for correlation. If you have correlation test and you got 0, it means it's not good for your machine learning algorithm. The correlation strength is none. Okay, if you find 0. If you find the positive, then very strong. In positive, it's negative. Then in reverse, it's a strong. Okay. This is the basic background to find out the statistical test. It's very important. And then after, this is the steps. As I told you, and I taught these things in my students also. And these students get very good output as a research paper. In very few months back, we got accepted back-to-back papers using these concepts that I have explained in this session for all of you. Okay, these are the few things, and if you have any questions, then you can ask. Thank you, everyone.
Thank you, Sumit. Actually, one question from one participant named Abhishek. Can we project in combination in data science and blockchain?
Yes, hello.
Yeah. Am I audible?
Yes, now you are audible.
Okay. Actually, one question from one of the participants called Abhishek. Actually, can we project in combination in data science and blockchain?
Yes, you can. As I told you, it's independent of any field. If you have blockchain and some kind of data related to blockchain, you can find. I provided a lots of uh, sites. Here you go and find out blockchain. Okay, with your interesting like security in blockchain. Okay, then you find some kind of data set and apply these things, that operation I told you. Okay, you can do these things.
Yes, sir. Yes, sir.
And okay, any other question?
Yeah, audience, any other questions? You can also post in the chat also. Yeah, thank you, Sumit. Over to comparing team.
Yes, sir. I request the Honorary Secretary, IEI Salem Local Center, to propose vote of thanks.
Thank you. Most respected Honorable today guest, respected Salem Local Center Chairman, sir, respected eminent engineers from various organizations, professors from various institutions, respected members from the local center, state center, corporate and corporate members, and my dear students from the various institutions, a very warm good evening to one and all present here. I'm very much honored and happy to propose vote of thanks in this prestigious event, Engineers Talk Webinar Series number 3,